Hello class, and welcome to today's algebra lesson, which is about factoring in the form of x squared plus bx plus c. By the end of today's lesson, you will be able to factor these trinomials that specifically have a leading coefficient of 1. So when we are looking at these trinomials where we have x squared as our highest degree value, this expression is called a quadratic. So it's the expression that has the variable, again, to the second degree and is written in the form ax squared plus bx plus c, where the a cannot be 0. Obviously, if the a would be 0, we would have 0 times x squared. 0 times anything is 0, and then that would go away, and we would be back into just a linear expression. So we have to have that x squared, or that variable squared, within our problem. Today's problems will all have an x squared value where your leading coefficient is 1. So I just want to review really quickly how we would have gotten to that trinomial to start. So in the first part of this chapter, we looked at this box method where we took our two binomials and we multiplied them together to get x squared, 7x, 5x, and 35. Then when we put it together for our final answer, we were at x squared plus 12x, because we had 7x and 5x, and then plus 35. So in the first part of the chapter, we were given the binomials, and we multiplied to get to this trinomial answer. Now we are going to be given this trinomial, and we're going to be unpackaging the box in order to get the two binomial answers. So we're going to be working back up to this original part. So, for example, we've got x squared plus 6x plus 8. What we're going to do to start is we are going to look at this third value in the trinomial. So we're going to look at the numbers that multiply to an answer of 8. So I'm going to list out factor pairs just like I did for the GCF. I've got 1 and 8 and 2 and 4. Now I need to decide which of these two pairs can combine to give me 6 x's. In this case, it's going to be the second pair. 2x's plus 4x's is equal to 6x's. So how does this come back to our box? So I have this box that normally when I did it in the first part of the chapter, I had the outside values. Now what I have is the interior values. So I've got x squared. So in the top left corner of your box is always going to be the first piece of your trinomial. In this bottom right corner is always going to be your back factor. And then this 6x needs to get split up into these two boxes. How are we going to split that up? Well, that's where these factors come into play. I can put 2x and 4x, or I could have switched to those values. I'll show you why in a minute. Now, how do we get out of the box? We're going to pretend for a minute that this part doesn't exist. And we're going to look at just the greatest common factor, so the thing that divides both of these two values. I've got an x squared and an 2x, so the only thing I can take out of both of them is an x. So that greatest common factor goes at the top of our box. Then I need to decide how to get back to these two inside factors. So to get from x to x squared, I need another x. So x times x gives you x squared. Then I need to decide how do I get from x to 2x, and that's by multiplying by 2. So we've dealt with those first factors. Now that I have the first factor, I can construct that last piece of my box, which is saying how do I get from x to 4x and from 2 to 8. Both of those occur when you multiply by 4. So my factors here are going to be x plus 2 and x plus 4. Now, what would have happened if I had decided to fill in the box in the opposite order? So to put the 2x and the 4x in the opposite spaces. So the x squared and the 8 can't move. That's still our first term and our last term. But if I had decided to flip-flop those and put 4x here and 2x here, we still need to start by looking for the greatest common factor, which again is x. Then we say x times x gives us x squared. X times 4 gives us 4x. Then x times 2, and 4 times 2 is 8. So it gives us that same factor pair, x plus 2, x plus 4, no matter where you put those two factors into your box. Go ahead and try this one on your own. So we list out our factor pairs of 1 and 21, 3 and 7. To get to a negative 22, I need a negative 21 and a negative 1. So I put those into my box and I get m minus 1 and m minus 21. Again, same kind of idea here. We are looking at this back factor to start. So negative 18. I'm going to start with 1 and 18, then 2 and 9, and then 3 and 6. Now, because it is subtracting 18, that means that one of my numbers in the pair that I pick out has to be negative. So I'm looking for something that's going to subtract to negative 7. In this case, it's going to be a positive 2 and a negative 9 to give us that factor pair. So when we set up into our box again, that front factor of x squared always stays in the first box. So we've got the x squared going in that top left box. Then we have the, in this case, negative 18 going into this back right box. Then we can decide if we want to put 2x or negative 9x. I'm going to put 2x here and negative 9x here. Then once again, we can ignore this second half of the box for a minute and look at our GCF of this first part. We can take an x out of both of them, which means I need an additional factor of x to get to x squared and an additional factor of 2 to get to 2x. Then we look across to get from x to negative 9x, and to get from 2 to negative 18, I need to multiply by negative 9. So my two factors are x plus 2 and x minus 9. Again, one thing I didn't say on the first couple, but I said at the end of the last video, it doesn't matter which order you write those factors in. So if you wanted to write x minus 9, x plus 2, and switch which one comes first and second, that is acceptable. It doesn't matter the order. The key is that the positives and negatives, so the negative 9, the positive 2, stay together. Go ahead and try this one on your own. So we've got our factor lists for 48. We need to get to a positive 13x, which means I'm going to do 16 minus 3, or negative 3 plus 16. We fill in our factors, and we end up with x minus 3, x plus 16. So on this one here, we are looking at our back factor, and in this case, I've got 90y squared. We're going to hold on that y square part for just a minute and start with our regular factor groups. So we've got 1 and 90, we've got 2 and 45, we've got 3 and 30, and then 5 and 18, 6 and 15, and 9 and 10. So now we are looking for a factor pair that can get us to negative 19. So I'm going to go through and look, and when I get down to this bottom factor pair, I can have a negative 9 and a negative 10 to get to a negative 19. So when I start filling in my box now, I've got in the top left corner my front term, which in this case, again, is just x squared. Then I fill in my bottom right with my back term, which is 90y squared. Now, when I fill in that middle part, I have negative 19xy. So I'm going to put negative 9xy in the first box and negative 10xy in the second box. Again, you could flip-flop which one goes in which box. Then I'm going to go ahead and pull out, after ignoring that part, my greatest common factor of the first two. The only thing that they have in common is x. So now to get from x to x squared, I need another x. To get from x to negative 9xy, I need a negative 9, and I also need a y. So then we look across. To get from x to negative 10xy, or to get from negative 9y to negative 90y squared, I need a negative 10, and I need a y. So my two factors here are going to be x minus 10y and x minus 9y. Again, you could have it in either order with the minus 9y or the minus 10y first. Go ahead and try this one on your own. So we list our factors of 57. To get to 16, I have a negative 3 and a positive 19. Pulling out our factors and closing our parentheses, we end up with x minus 3y and x plus 19y. Looking at this one here, I'm going to jump to the back, and I've got positive 60. So I've got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and our last pair of 6 and 10. I am trying to get to an answer of negative 14, but no matter how I try adding or subtracting these factors, no single pair can get me to an answer of negative 14. When that occurs, if you have made your factor list and there are no pieces that add or subtract to this middle value, we call this a prime trinomial. So this is something we can't break down into any further factors. Quick tip. If you have a positive c, so if that third term is a positive value, both factors are going to have the same sign. So it's either going to be x plus something and x plus something, or it's going to be x minus something and x minus something. So if you have that last number is a positive, it's either going to be 2 pluses or 2 minuses. If it is a negative factor for c, so that last value, that last term in your trinomial is negative, you're going to have one that needs to be addition and one that needs to be subtraction. Could be subtracting first and adding second, but it has to be one of each. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.